You guys hear me okay?
Yep.
Outstanding. So today I wanted to take the lecture time to sort of pull together all of the thoughts and all the things we've been talking about in the class, and talk about what does that all mean and where is manufacturing going from here. Um, I also want to just talk about sort of the overhead associated with finishing up the class. We've got a couple things left to do. Um, if anybody that has not yet taken their lab practical exam is worried about it, I don't want you to be worried about it. In fact, the only way to get a grade lower than 75% is to not take it. So nobody can fail that exam if they take the exam and if they ask questions when they need help. But everybody that took it yesterday got 100%. And the normal grade on the test is 100%. And a few people get 5 or 10 points off. There's 5 things that you need to do. You need to demonstrate that you know how to do those 5 things in order to pass the class. It's the things on the checklist. So on the safe operator checklist, if you can do the steps on the safe operator checklist, you can pass the exam with 100%. If you forget how to do one of the steps, but remember that you need to do the step because the checklist is open in front of you, you can ask the PLA how to do that step and they will tell you, and they will deduct 5 points from your score. So it is not intended to be hard. It's like a driving test, except you can ask the driving instructor who's giving you the test, how do I make a left turn? So it's really not intended to be difficult. Don't be worried about it, please. What else? Oh, so all of the assignments, with the exception of the lab practical and the final exam, have unlimited attempts. And I've mentioned in class several times, I will not be deducting points from any assignment if it's handed in late, which means on any of those assignments, if you're unhappy with your grade, you could go back and try to fix the grade and get that up. And but please, and you'll see, I got a few people who've been doing that and submitting some CAM assignments and stuff like that. I would ask you, if you're going to resubmit a CAM assignment, make sure it's actually correct before you resubmit it, because it's frustrating to have actually talked to the student about how to correct their problem and then have them submit something that's not correct. So feel free to talk with the PLAs, talk with me, make an appointment with me to go over it with me before submitting it. And that way it shortens the feedback loop. So I can tell you what's wrong while we're talking about it, as opposed to having to exchange conversations in the comments in the gradebook. What else? So please take time, if you want to go back and improve your grades. I'd like to play this video. Have I played this video in class? No? I don't really want to. I'll save it for the end. If we have time at the end, we'll play the video. If not, you guys can watch it because it's in the Canvas site. It's one of my favorite all-time YouTube videos. And it's pertinent to today's discussion. Future of manufacturing. All right, questions. All right. Lab practical, don't be afraid. It's supposed to be, if you've been going to lab and you know when you get to the edge of your knowledge, it should be easy. The other thing you're doing in lab this week is assemble your Stirling engines. And we have this, how much is that going to cost exercise? And I know that from conversation I've heard that a few students have been concerned about this assignment too. And this, again, was not intended to be difficult, but it was intended to allow you to think about these things we've been talking about. And it's sort of lined up with today's lecture topic of tying together the things we've talked about in the class. And I wanted you to think about it in a way that's different from the way we've been talking about it in class also. And so again, that's not intended to be it's not intended to be difficult. It's intended to make you think and maybe think from a different viewpoint also. But if you come, I actually, this is, that's actually not the assignment. That's what I copied and pasted from to make it. But I changed the way the assignment was deployed. Let me go back. It's in here, right? If we go to assignments and we come down here to other assignments, how much is that going to cost? All right. So I changed the deliverable to make it simpler and easier for you to do. So instead of, if you've already done this and you want to submit that, don't go do the other thing instead. But to get full credit, just answer the questions in the business plan outline below. And then we have a business plan outline here. And so it says we are seeking blank dollars in additional working capital, which we're going to pay back over these 3 years of this much per year. And so you can't answer this until you've answered all the other questions, but that would go at the top of your request. You're going to use the information. All right. So use the information presented below to determine these numbers. So go to someplace like LoopNet or some other realty site and find a place that you could potentially rent that would be big enough that you think would be a place to do it. So go out and actually look at a couple places. When we did it in lecture on Thursday, I think I found 5 or 6 potential locations within 5 minutes. And just pick one, and they put the average. And I showed the calculation for going from. So it's so located in, say, located in Worcester. Maybe you don't want to be in Worcester. Maybe you want to be in Lowell or Framingham. So located where, and this is how much per square foot per year. And so if it's 100,000 square feet and it's $12 per square foot, or sorry, if it's a 10,000 square feet and it's $12 per square foot, then how much is it? So if it's 10,000 square feet and it's $12 per square foot per year, it's $120,000 per year to lease that facility. All right, we did that on the board. And so find something that you could use. In lecture on Thursday, we said, let's estimate $15,000 per year for things like utilities and insurance and other overhead expenses. As discussed in class, all right, so we'll buy or lease the following machine tools. So pick the machine tools that you think you want to own in order to make the Stirling engine parts. So go to the Haas website, get an instant quote that takes, again, about 5 or 10 minutes per machine tool to get the price. Then you can decide if you want to buy those and ask for that money as capital, or if you want to lease those, in which case you can go to, if you Google commercial leasing calculator, you'll find hundreds of sites that you can put in the amount. Say you want to pay it off over 5 years or 3 years or whatever you choose, and it will tell you the monthly payments. If you're doing it by a lease, then you could pay for them with the money you generate in revenue by selling your Stirling engines. If you buy them, you're going to have to ask for that capital from your venture partner or bank, whoever you're submitting this business plan to. So pick out the machines that you want to use. Decide how many people you want to employ and how much you're going to pay them. We said that operators around here get about $50 an hour. Decide if you're going to do some of that work. And these numbers, you can change this. So down at the bottom, you can feel free to include any supporting tables or graphs. So this number could change over time. So maybe you'd start with 1 employee, you add 3 more in the second year or something like that. You can build that out. Just make sure you include supporting information about that down here. Cost of materials. So go to mcmastercar.com, find out how much it's going to cost to buy the materials to make each Stirling engine. So what's the material cost for the raw materials? You can get that from McMaster-Carr. And then set the engine price point, something higher than the cost of materials plus labor. Then you have a profit. Out of that profit, you can pay back this money up here. So it's really just intended to make you think about what goes into running one of these facilities and what are the costs. And so if you can answer these questions, then you get full credit. So it's not intended to be hard, but it is intended to make you think about it. The final exam is posted. If you're remote and you're not on campus, so you can't do the in lab practical, I posted in the assignments. There's a remote student lab exam. Now, no matter whether you're doing the lab practical in the lab or you're doing the remote student lab exam, one of these grades is going to be 0. And because of that, I will have to manually adjust your final grade at the end because the grade book will factor one of those grades as being 0, but I'll fix that before we publish the grades. So you can factor that out. If you can all do averages, right? I'm assuming you can all calculate an average, and you could probably do a weighted average. So you could figure out what your grade's going to be, even though the lab practical portion of your grade will calculate incorrectly in the Canvas gradebook because of the 2 different types of lab practicals. All right.
Quick question.
Yep.
When calculating the like amount that the stirring agent costs, do we include like a candle / like fire source, or do we not include that in the price?
That I would say ask your marketing team. It's actually a really valid question. It depends on what are you going to package with the Stirling engine. You can leave that out or put it in. It's really up to you there. For the numbers part of this, there really aren't any right answers and there aren't any wrong answers. There are reasonable answers. So if you say that the Stirling engine is going to cost $1,000 to make for materials, I'm going to know that you didn't bother to look up how much materials cost because it doesn't cost that much. It costs something around the cost of your lab vouchers. And because that's what the cost of the lab voucher is based on, is how much it costs us to buy the materials and the tooling so that you can make these. So I know for a fact that the cost of making a Stirling engine is somewhere between $50 and $70. If you say, well, we're going to make them at $70 and we're going to sell them for $10,000 each, that's probably not reasonable either. But if you go online and find some other gadgets that are sort of like this, you'll probably see that they're priced at around $100 to $50, somewhere in that price range. So you can just pick a price point because you get to decide those things when you're making when you're forming a company, you get to decide how much are we going to charge for our thing. If you charge too much, nobody's going to buy that. But we're not going to get into modeling this and see if it would actually work. I just want you to make some reasonable assumptions and some choices that sound like they would work. So again, with this assignment, the way to not get a good grade on the assignment is to skip some of the steps or to not do the assignment. And I think that's pretty true of most of the assignments for the class, is the way to not get a good grade is to not do it. So make some reasonable assumptions. Did I answer your question? I kind of went down a tangent.
Yeah, I'd say so.
Okay, good.
Professor Bergstrom.
Yes.
So if we're planning on having our facility located in a different area of the country, how do we say that we're going to be somewhere other than Worcester?
So
right?
Where'd it go? No, not lab practical. Other assignments. There it is. So when you get to the outline here, we will lease a blank square foot facility located in, you can put it there. So you could say Asheville, North Carolina, if you want to rent on the Biltmore Estate property. That's probably expensive, but it would be a really cool place to be.
Okay, thank you.
Yeah. And again, I put on the schedule for this week. Where is it? Home. So I put in the schedule for this week. So I will be on Zoom tomorrow at 11. Oops. And Thursday at 8 for people with questions. That could be questions about the exam, questions about questions about this assignment, or if you're trying to figure out what did I do wrong on cam number 3, you could bring that. You can share your screen, and we can figure out what you did wrong on cam 3. So I'll be available during all those times for questions. And again, you can always go to professorbergstrom.com/schedule and make an appointment. And if it's a phone call, they're available from like 6 a.m. till 9 p.m. or something. So depending on the day. So that's what I got going for this week. And if you have questions, feel free to interrupt. But what is manufacturing? This is how we started the class. So let's end the class with the question, what is manufacturing? So what is it? We just did a whole term about it. What is manufacturing?
Making a product.
Making a product, somebody said. Okay. So it's making a product. What makes it a product?
Something people will buy.
So a product is something So a product is something people will buy. How do you know they will buy it? You know they will buy it because they did buy it. So you believe you have a product right up until the customer pays for it. And so the value of the product to me as the manufacturer is how much the customer decided to pay for it, right? That's the value to me because that's what I got for it. That's what I got in exchange for giving it to the customer. What's the value to the customer? So this is the value for the manufacturer. So let's call that V sub M. So V sub M, that's the value of the manufacturer. What's V sub C? So we know the value to me is the amount the customer paid. What's the value to the customer? What should it be? We don't really know what it is, right? But what should it be? Should it be greater than or equal to V sub M? So the customer won't succeed very well if they give me more for my product than it's actually worth to them, right? And most customers would like to give me less than the product is worth to them because then they get a little bit of a profit, right? So value to the customer is going to be greater than or equal to the value to the manufacturer. Okay. Now, why do we do manufacturing? Why do we decide to create a manufacturing company?
We think we can make a profit somewhere.
We think we can make a profit. Actually, for me, it was because I always thought it would be cool to own a factory where people were working while I was not working. But you can't do that for very long if you don't also make a profit, right? So we create our manufacturing company because we want to make a profit. What's profit equal?
The price people are willing to pay minus the price it costs to produce
So P sub M minus cost, right? And we'd actually like to have a profit rate. So we'd like to have a profit over time. And then we just put this over time. And we could decide to make our time units big or small, depending on what we want to talk about. But we'd like this number, this profit over time, to be a positive number, right? And the bigger positive number we have here, or the longer time, the more wealth that we're able to acquire for ourselves. So value minus cost over time, profit rate. We want this to be positive, greater than 0. Okay, so we create a manufacturing company to make our profit rate greater than 0, but we also know that we've got to be able to have our price point be low enough so that our customer will value the thing that we're selling more than we value it, right? Otherwise, they're not going to buy very many of them. They won't keep buying them for very long. Okay, so this is manufacturing. This is the product side of manufacturing. And if you understand the product side of manufacturing, you really understand products and you can figure out selling from that. What about the making side of manufacturing? Because that's really what this class is about, right? How do we make stuff?
We've got milling and turning, or milling.
So we could do milling, turning, grinding, assembly. Any other ideas? These are the, I mean, did we do any grinding in this class? No, we probably didn't do any grinding in this class, but we'll do milling and turning and assembly in this class. What are other ways we make stuff? Sewing. Anything else?
Additive, like 3D printing.
Printing. How else?
Extruding.
Extrusion. What else?
Bending.
Bending. Like yoga. What else? There's a lot of processes, right? These are all processes. So the processes, so making is taking raw materials, putting them into a box that contains a process, taking out something else, something of higher value. We'll call it a product. And the reason we know it has higher value is because our customer paid us more for it than we paid for the raw materials plus operating the process, right? But making is taking raw materials, turning them into something else, something preferably that the customer wants that has a higher value than the raw materials plus the process added together. So it's manufacturing. What's the future of manufacturing? Is it always going to be making stuff that people want? So the future of manufacturing equals the present, right? It's going to be making stuff people want, and making is taking raw materials, applying a process that increases the value of the raw materials. So why should we have a lecture about advanced or the future of manufacturing? Often people say the term advanced manufacturing is one of those technobabble words that we hear. So why should we talk about the future of manufacturing? What's going to change?
I think it should be more sustainable, like with the
We
product.
can make it more sustainable. All right, I gotta erase my whiteboard. So it's always going to be making stuff that people want, but the future should be more sustainable. Now, I think I know what you mean by sustainable, but could you clarify what would determine if it was more sustainable?
Like the materials we use are recycled, and like the processes aren't as wasteful and don't use up as much like fossil fuels and stuff.
So recyclable, less waste, and more energy efficient. So manufacturing should become more sustainable by having recyclable end products, generating less waste while we create the end products, and using less energy. Is there anything else that would go into sustainable? When you submit your business plan to the bank, you should say that you're going to do sustainable manufacturing, because the bank's interested in that right now, because they know that customers are interested. Is there anything else that goes into sustainable?
Maybe designing a product that will last.
So rather than be able to recycle it, have it last longer. And maybe be recyclable, right? So it doesn't have to be or. Anything else that goes into sustainable?
Not only that it can be recycled at the end, but that the materials you use at the beginning are recycled materials rather than new materials.
Start from recycled materials. I guess all materials are recycled at some level, right? They were all once part of the sun or cosmic dust. We don't want to get that philosophical. Anything else that sort of comes to mind for sustainable?
Maybe possibly longer lasting tools, or like more.
We could reduce waste by having better tooling. And there's a lot of stuff that you could do here with reducing the waste, because you could have more environmentally friendly coolant, for example. You could, if your process requires oil, you could use less oil, or you could find a mineral oil to use, or even a vegetable oil to use. And there are all of those kinds of things going on in manufacturing right now. So I think maybe this was implied because we said we were doing manufacturing, but I think we also have to be profitable. Because if we can't be profitable, it doesn't matter if we do all these other things, we're going to go out of business. And so if we're doing these things, do these things cost more or less money?
Or
Let's vote in the thing. So say yes if you think it's more money, and no if you think it's less money. All right, so the consensus is that it may cost more money, except if we're really, really good at this step, the less waste, and we're really, really good at the more energy efficient, it's possible that it costs less money to do these things than it does to do it the old way. So I think we don't have enough information to actually answer that question, but intuitively we feel like it's more expensive, but it's not necessarily more expensive. And even if it is more expensive, all we've got to do is convince our customer that there's more value. They will pay us more, and then we'll be able to stay profitable. So some of it's got to be marketing. All right, so we'd like the future of manufacturing to be more sustainable. What else do we see in the future of manufacturing? And I said we often call this advanced manufacturing also. And I had a conversation with our department head about what is advanced manufacturing, because there's a lot of people that use this word, and I think even our laboratory is called the Advanced Manufacturing Laboratory. And I've taught classes in advanced manufacturing, but I'm not really sure what advanced manufacturing is, because some of the most advanced manufacturing I do is the same physical process. It's the same physics that we were doing in the 1700s. Now I got better computers than they had in the 1700s, but the physical process is the same. And so talking to the department head, the question came up, what is advanced manufacturing? I think he was leading a seminar or a panel on advanced manufacturing. And so I asked him this, and he said, it's whatever the National Science Foundation is funding this year. And so it's really a gray area what's advanced manufacturing, but the future of manufacturing, that's things that we're going to be doing. I agree that the only way to remain profitable is going to be to reduce waste. The only way to remain on the earth for generations and generations to come is going to be to figure out how to be more energy efficient and to use recycled goods and to recycle more, to make our parts last longer so they don't need to be recycled as soon, which again reduces the energy cost, the energy load. But what else? And so the National Science Foundation funds, they do fund sustainability initiatives. But what they really get excited about is new manufacturing processes. That's what people talk about when they're talking about advanced manufacturing and the future of manufacturing. So I'm not sure that that's what we should think about when we talk about the future of manufacturing. Processes have changed. Processes are going to change and evolve over time. Eventually, we will be 3D printing by placing atoms next to each other and building molecules. We're not doing that today, although there are some people getting close. So what is the future of manufacturing for you as you go into the workforce? What's the future for you? What are we going to do in the near future that's going to be important in manufacturing? Does anybody know what the biggest problem is in manufacturing today?
Automation.
The biggest problem?
I guess it's not really a problem, but
automation is definitely one of the solutions to what I say is the biggest problem in manufacturing today. But does anybody know what the biggest problem is in manufacturing? If you go to any manufacturing summit, if you talk to any head of any large manufacturing company, they will all tell you the same thing. If you talk to government officials that deal with manufacturing in the manufacturing industry, they'll all tell you the same thing as the biggest problem. It's been the biggest problem for the last 15 years. Maybe
Not
2.
enough people are going into it.
So we got less young people going into manufacturing and more old people retiring. And so they call it a skills gap. And the last study that I read that was talking about the skills gap at the time, I think the US unemployment rate was around 10 or 12%, something like that. Maybe it was higher. The unemployment rate was higher at the time I read the study, or the time the study was conducted. But the study concluded that there were 600,000 unfilled manufacturing jobs. Unfilled because they couldn't find anybody with the skills to do the jobs. And that doesn't count the jobs that didn't get created because the business owners knew that they couldn't find anybody to do those skills. That counts the jobs that existed that people left from. They say as more and more of the baby boomers start retiring, we lose the knowledge that they had. A lot of this knowledge is the things that I know how to do that nobody ever wrote down, but I know how to make good parts on that machine, or I know how to design good parts that machine can make. So the skills gap isn't just at the operator level, it's all the way up through the engineering fields. As those people retire, not enough people learned those skills coming in, and the knowledge is disappearing. So how to do some of the things that we had to do in order to build the Apollo rockets, or to build all of those Liberty ships that we had to build to get past the U-boats. The skills that we developed in order to do that, some of them don't exist anymore. And we compensate for that with faster computers and mostly with faster computers. That's probably not good for society long term. But the skills gap is the biggest problem we have. We could, sometime when we've all graduated and we're back for an alumni thing, we could sit down over beers and we could talk about whether this is good for society or not. But how are we going to fix the skills gap? So automation is one tool. Is it the only tool? So how do we fix our skills gap? We need our manufacturing companies to have more automation. And in fact, I'm supposed to be at a seminar about automation right now, but I'm here with you guys. What else besides that? How do we fix the skills gap?
By training more people in those skills.
Training more people. So we can train more people and we can make the skills no longer important. Right. And so things like automation, CNC, which is just a kind of automation, right? CAD, CAM, right? When I learned CAD, I no longer had to remember how to roll my pencil as I made the lines on my drafting table in order to make sure that the line thickness stayed the same all the way across the line. Because in my CAD program, I have a little drop-down window and I can select the line thickness. And I can change it after I've drawn it too. So I can make that skill that I had to learn, but you didn't have to learn, about rolling the pencil to keep the line thickness the same. So we can make the skill no longer important. The problem is if all our computers crash, then we're going to be screwed because nobody knows how to roll their pencil anymore. How do we train more people?
Get more people interested in the subject.
So first we do marketing, right? We're going to get more people interested. What else do we have to have? If we're going to train a lot more people, we need more trainers. How do we get more trainers? I convince you guys to become an engineering professor so that you can train people to do things like this, right? What do we do at WPI to get more trainers? You've seen it.
PLAs.
We have PLAs, right? We take people that just learned and we help them teach the new people while we're still teaching them more stuff, right? So we can delegate the responsibility of training. I think the most successful manufacturing engineers and the most successful really engineers in general that leave WPI and go into industry, and probably for the next 50 years, this is going to be true, are going to be the people that, one, can think of ways to design around the skills that we've lost. So to design things more intuitively so that you don't need to have the same level of skill for the operator to perform the operations, but also who can recognize new technologies and new tools and can quickly train people to use those tools to make the things that their company wants to make in order to remain profitable. So there's two really important skills in manufacturing that have nothing to do with understanding chip formation and have nothing to do with knowing how to load a part in a CNC machine necessarily. They don't necessarily have anything to do with that. But it's going to be this skill, one, to recognize and understand how to make things simpler to make, because there aren't that number of skilled operators in the workforce anymore. And two, how to take somebody off the street and teach them the skill that they need to do the thing that you designed or programmed, or the process that you programmed. Those are going to be the most important skills that you can take with you from WPI when you go to industry. And it's going to be people that do that succeed when they graduate, when they get into industry. Why is it important? Couldn't we just get everything made in China or Malaysia? I don't want to pick on the Chinese or the Malaysians. We could do Indonesia, Vietnam, Brazil, Mexico. Can't we just outsource all our manufacturing? There's still people in those countries with skills.
No, there's less jobs if we do that.
There's less jobs here. We could all get a job in the service industry, right? Plenty of people want fast food. So it does export jobs, right? It moves the jobs somewhere else. Automation creates fewer jobs too. Why is automation way better than outsourcing?
Someone still has to control the AI or robot that's ever doing their job.
So let's go back to and I agree that's correct. Let's go back to our initial question of manufacturing and profit. So we've got our V of manufacturing. And we get our V of the customer. And this has got to be greater than or equal to this, right? And this is VM, so profit. I can put those two closer together. So VC has to be greater than or equal to VM. All right, we got that. Profit equals VM minus cost over time. What's profit? It's the money that's left over, right? This is the money that's left over. What happens to it? What happens to the profit in a manufacturing company?
It goes to the employees and then back into the company or back to the investors.
Profit. Some of it goes to pay back investors. Some of it goes to the employees. Now, this depends on the company management, right? They don't have to share the profit with the employees because they already paid the employees their salary. But let's just assume that the company management is cool. And so some of it goes to pay the investors back. Some of it goes to the employees. Most of it usually goes to improving the company. Usually expand. When we expand, we get more if we expand, we get more employees. So profit's really good because it pays back the investors who gave you their money so that you can start your venture. You share some of it with the employees directly, and you improve your company by expanding it and then needing more employees. And if you're doing that manufacturing here, then this money stays here. Even if you're automating, and so maybe you're improving the company, you're expanding, you don't need as many more new employees because you've automated, you're still keeping that money here, which means we can grow the wealth here and all it's, the tide rises and the harbor and all the ships go up, right? If we outsource our manufacturing, there still will be wealth generated, but it's going to be generated somewhere else. And I suppose in a global economy, I shouldn't care. In our new, smaller world, I shouldn't care, but I really want my neighborhood to be nice. And I want your neighborhood to be nice. So it's important to do manufacturing because where we do manufacturing is where we create new wealth. This VM has to be less than, right? Or equal to VC. VC has to be greater than or equal to VM. This part, the greater than or equal to, is the magic. That's wealth. And so if we're making wealth here, our lives are better. And then we can share with everybody else. So those are my thoughts on manufacturing, why manufacturing is important and why you should continue to learn about it even after this class is over, which happens in about, like 25 seconds ago, except for all the exams and the grading and stuff. I can do questions right now. I'll be on tomorrow morning at 11 for questions and Thursday at 8 for questions also. And thank you all for being here.
Thank you, Professor.
Thank you.
Thank you.
Thanks.
Thank you very much.
Thanks.
Thank you.
I had a question about the final exam.
Sure.
Not the final exam for people who aren't on campus, but like the campus quiz. I know that you had mentioned previously that if we needed help on quizzes, we could reach out.
Yeah, absolutely.
I like reach out to friends and stuff. Are we allowed to do that on the final, or should that be a singular effort?
I normally make you answer a question at the first question on the exam that says you will not reach out to friends and family and ask for help. You'll do this all on your own. I didn't do that this term. So I guess that means that it's okay for you to reach out. All my exams are open book, open notes. All my tests are open book, open notes. The premise being that engineers don't work in a vacuum. One of the things that can be valuable for engineers is to know who to ask when you have a question. So if you have a targeted question, but don't ask what's the answer to this. That would be cheating. But asking how do I figure out the answer to this? That's a fair question to ask somebody. Is that fair? And if you do ask that way, I won't know anyway, but don't tell anybody I said that.
Okay, thank you so much.
Yep.
I had a small question on the we will employ machine operators part of the revised business plan.
Okay.
Does that still follow the like the three of us can be working and we don't have to take a salary until X time? All that.
Yeah,
Okay.
you can do that. But if you do that, if you're working and you're not taking a salary, the person you go to with your business plan is going to ask the question, how are you going to support yourself? So if you do that, put in a note about how you're going to eat.
Okay.
If you're not paying yourself anything.
All right. Thank you.
But you can certainly pay yourself less than what you would have to pay somebody else, and it's reasonable.